Hey, how y'all doing out there? It's Brother DeVoe, just chilling on the weekend, and we got Unit 7, Concept 6 coming up, and figured why don't I just do a couple of examples with you before you guys do it yourself. This topic for Unit 7, Concept 6 is called Factoring Differences of Perfect Squares. And before we get into factoring differences of perfect squares, probably a good idea to just remind ourselves of some of the key words here. That first one is difference. So why don't you take time real quick and we're not talking about the difference. My dog is a different pet than my cat, or you and I may look different or have different heights or different ages. We're talking about the word difference in terms of mathematics. So why don't you pause the video real quick and write down what do we mean by difference when we're talking about mathematics. All right, so hopefully you remember that difference is our answer when we are subtracting. So, right, difference is the answer when that's what we call the answer when we're subtracting. Let's put that in here. So if you're subtracting two numbers, we'll call that answer the difference. Now let's talk about perfect squares. That's something you probably heard before. Maybe it's been a while. Let me refresh your memory. Let me give you a few of them real quick, and let's see if it jogs your memory. Let's start with some small ones. 1 is a perfect square. So is 4 and 9 and 16. And of course, there's some big number of perfect squares too, like 121, 144. Even with variables, x squared, x to the 6. All of those guys are perfect squares. So why don't you pause the video real quick and see write down what do you think we mean when we talk about a perfect square. What do these numbers or terms have in common that makes them a perfect square? All right, well, hopefully you saw that each of these terms can be written as another number squared, right? So 1 can be written as 1 squared. That's what makes 1 a perfect square. 4 can be written as 2 squared. 9 can be written as 3 squared. 16 can be written as 4 squared. And you can see, just like we have infinite numbers, we have infinite perfect squares. Because any number you pick, if you square it, you're going to get a perfect square. Right? It just goes on forever. 121, that's a perfect square because that could be written as 11 squared. 144 can be written as 12 squared. And like I said, this doesn't end. If you did 1 million multiplied by 1 million times itself, you would get a perfect square. But what about this, Brother DeBow? X squared and x to the 6. Why are they perfect squares? Well, let's see. We said they're perfect squares if we can write them as a number or term squared. Can I write x squared as a term squared? Well, sure. X squared is just the variable x squared. So x squared is a perfect square. What about x to the 6? Can x to the 6 be written as something squared? Absolutely. How about we write as x to the 3rd squared? We talked about that multiplying monomials. If I multiply x to the 3rd by itself, x to the 3rd times x to the 3rd would give me x to the 6th. So anytime you see an even exponent, any even exponent is going to be a perfect square when you're dealing with variables. Right? So, because you could just cut that in half, and you'll have a term that could be written. If you square it, will give you the term that any variable going to an even power. All right. So the difference is we're dealing with subtraction, right? Perfect squares means you can write it as a number or a term multiplied by itself. So let's do a couple of examples together. We'll keep this video short. I'll do one, let you try a couple. We'll go through the answers, and then you can finish off this page in the packet. So let's take a look at what it looks like real quick. Let's take a look at an example right here. Y squared minus 121. First, before you use the factoring by perfect square method, make sure that it is a difference of perfect squares. Is it a difference? I see the subtraction sign, so it is a difference. Can I write these guys as something squared? Well, y can be written as y squared, and 121 can be written as 11 squared. So watch how this pattern, how this matches up, and then once you see it a couple of times, I think you guys are going to be able to do this whole page very quickly on your own. The way the pattern works is this. You see the y squared minus the 11 squared here. If you want to multiply it together and factor it, we're going to factor it into two binomials. That's going to give us y squared minus 121. Watch how we do this here. One of them we're going to make addition. It's going to be a plus sign. And one's going to be minus, right? Whatever that first term squared is, he goes in the first space in each of these binomials. So each of these is going to be y. The second number here, or whatever that second term being written squared, since 121 is 11 squared, we're going to write that 11 in both these boxes here. Alright, we got to the answer real quick. But let's take a moment to show why that's the case. Right, so we said this is the answer here. Why don't we check Brother DeVoe real quick. Do the box method and see if this is true. Alright, hopefully if you did the box method, as we already learned, and you said we're going to check our work. If we did the y plus 11 and the y minus 11, then we set up our box. So we have a 2 by 2 box. And then we multiply y times y. Well, there's the y squared. Okay, we got that. Let's do this last box down here. Negative 11 times positive 11. Well, negative times a positive is negative. 11 times 11, we says 121. You said, Brother DeVoe, that's all we got there is the y squared minus 121. What about these other two pieces of the box when we always multiplied? And then we get that middle term, that third term. Well, watch what happens here when we're doing the difference of two squares, of perfect squares. The y times 11 gives you a plus 11y. But then the y times negative 11 gives you negative 11y. So that middle term that we were getting before, when we were doing our box method, plus 11y and negative 11y is 0. They cancel each other out. Plus 11y and minus 11y is gone. That's what just leaves us with the y squared minus 121. That was our check. Keep in mind, though, don't get confused. I know sometimes we get the check that happens before. People want to circle the check. We were just proving that if we multiply these two binomials, we do get our original binomial. Your answer is right here. This is the factored form of y squared minus 121 equals y plus 11 times y minus 11. Alright, why don't we just take a moment real quick and why don't you pause the video and give this one a try. Remember, start off writing it as how can I write this as a number or term squared. Alright, hopefully you had some time with that. 49, hopefully you recognize 49 as 7 squared. I know you did. D squared, well, that's pretty easy. That's just the variable d to the second power. So, what's the form we just saw here? We're going to start off with two parentheses. We'll put plus and a minus. Then we need the plus and minus because we want that situation where the middle term was going to cancel out because we only want two terms here. So we'll put plus minus. By the way, it doesn't matter which one you put first, right? If we were to put minus plus, that's the same thing. In our box, we would just get a positive here and a minus here. Same thing would happen. Whatever this first guy is that was squared to get this, the 7 goes in both, in the beginning of both of these binomials. And then this term, the d, that's going to go in both. And once again, check that for yourself, but you'll see we'll get a 49 when we do the box method minus d squared. In the middle term, once again, you'll see will be a plus 7d and a minus 7d, which will cancel out. Go ahead and check that for yourself. Go ahead and do the check. And prove that these are the factors of 49 minus d squared. Oh, we're already over 10 minutes. I thought it was going to be a quick video. All right, let's just wrap this last one up. I want to give you an example. I think it's about 17 examples on the page. I kind of picked one where, you know, the variables, the first term, we got one with the variables, the second term. Both of these situations, the coefficient of the variable is 1. So before we go, let's make sure we look at one where the coefficient of the variable is not 1. This one looks a little bit different. 1 minus 144 p squared. Why don't you go ahead and hit pause, give this a try yourself, and then we'll come up with the answer together. All right. Did you get a chance to set it up for yourself? Let's see what we got. What was 1? How can we write 1 as something squared? Well, that's pretty easy. We got it right up there. 1 is just 1 squared. Minus, remember this was the difference of perfect squares, so notice we always had subtraction. If you don't have subtraction, you can't use this method. This method's only for difference of perfect squares. 144 p squared. Were you able to write that as a term? As something squared? Maybe a little challenging there. Well, let's look up. We already said 144 could be 12 squared. So let's get the 12 here. And then p squared, well, just like x squared can be written as x to the second power, p squared can be written as p to the second power. So our two terms we're looking at inside the parentheses, just like we used the y and the 11, the 7 and the d. This time we'll be using the 1 and the 12p. Same procedure. Set up your two parentheses for your two binomials. This is a special method that only works when we have the difference of two squares, of two terms that we can write as something squared. We're always going to do plus minus. This time I'll switch it up to show you it doesn't matter. I'll put minus plus. The key is that these terms are different so that the middle term does cancel out, because we only want two terms left here. Whatever term is being squared here, that's going to go first for both binomials. And whatever the second term is being squared to give you that second piece here, that 12p, that whole thing will go into both. And, oh, I can't believe the video's already up to 13 minutes. Time flies when you're having fun. Hey, take time to do the check for yourself. See the middle term cancel out. We'll put a couple of questions in there on Edpuzzle for you to try yourself. And I believe after you get some practice with it, you'll see it's one of probably the easier ways to do some factoring. And we'll do some more methods later on this week. All right. Look forward to seeing you guys in class on Monday. Take care.